Today we will talk about eightfold way in particle physics. So what is eightfold way? Why we use this? We have so many elementary particles, so it is difficult to remember these all. So scientists always try to gather these particles according to their properties so that it becomes convenient for us. For example, scientists took many time to gather elements in periodic table according to their atomic weight and atomic number. In 1950 century, Enrico Fermi said that young man, if I could remember the names of all these particles, I would have been a botanist, not a physicist. Before starting my lecture, once again, I am suggesting you all that please go in my first video, that classification of elementary particle, because without this you can't learn particle physics. If you know this chart, then you will categorize that okay, these particles are mesons and baryonic number for these particle equals to 0 and etc. So please remember this chart. At first, come to our first eightfold way for mesons. Which particle comes under mesons? Kaons, pions, and eta naught. Why we call eightfold way? Because 8 particle comes under it. So if you move diagonally, so for first diagonal, pi negative and chi negative, charge will be -1. And if you go in second diagonal, then charge will be 0 for these all particle k naught, eta naught, pi naught and k bar naught. And if you move in third diagonal, that k positive and pi negative, pi positive, so charge will be +1 for this particle. If you move horizontally, then strangeness equals to 1 for k naught and k positive. If you move in second horizontal line, then strangeness equals to 0 for pi negative, pi naught, eta naught and pi positive. If you move in third horizontal line, then strangeness equals to -1 for k negative and k naught bar. Similarly, isospin will be half for first horizontal line, isospin equals to 1 for second horizontal line, and isospin equals to half for k negative and k naught bar. Let's go to our second eightfold way. For vector baryons, again we have eightfold way. Which particle comes under it? Neutron, proton, sigma negative, sigma naught, sigma positive, lambda naught, cascade negative, cascade naught. So one generalization we have that baryonic number equals to 1 for these all particles. And all spin have half, means these all particles are fermions. So if we move diagonally, then charge will be -1 for sigma negative and cascade negative. And if we move in second diagonal, then charge will be 0 for neutron, sigma naught, lambda naught and cascade naught. And if we move third diagonal, then charge will be +1 for proton and sigma positive. If we move horizontally, then strangeness equals to 0 for neutron and proton. And if we move in second horizontal line, then strangeness equals to -1. And if we move in third horizontal line, then strangeness equals to -2. And isospin equals to half for first horizontal line, isospin equals to 1 for second horizontal line, and isospin equals to 1/2 for third horizontal line. So we have another category of elementary particle known as resonance baryons. in which we have 10 elementary particles: delta negative, delta naught, delta positive, delta double positive, sigma ascaris negative, sigma ascaris naught, sigma ascaris positive, cascade ascaris negative, cascade ascaris naught, and omega negative. So if we move in diagonal, then charge will be -1 for this all, and the charge will be 0 for this all, and the charge will be +1 for this all, and the charge will be +2 for this all. And if you move horizontally, then strangeness equals to 0 for this all, and strangeness equals to -1 for this all, and strangeness equals to -2 for this all, and strangeness equals to -3 for this. Similarly, if we talk about isospin, then isospin equals to 3 by 2 for these all, isospin equals to 1 for these all, and isospin equals to 1 by 2 for these all, and isospin equals to 0 for this. And baryonic number will be 1 for these all.